So inside RAG component, you are having these are the component. So first of all, you have to split the data, then you have to generate the embeddings with the help of embedding model. Then you'll be storing that embedding to the vector store, that is vector database. Then we'll be creating the retriever. And if you want, you can also set the top k parameter. Then what you can do, you can perform the retrieve operation. Either you can perform similarity search operation. But whenever actually I was performing the retriever operation, similarity search operation, so it was only returning the similar kinds of response. Okay, like the best results, actually it was returning around 4 to 5 response it was returning, but that is the answer I'm not looking for. I'm looking for one accurate response. So if I want to get the accurate response, guys, what I have to do, I have to connect my large language model. Okay, after connecting the large language model, we'll be able to get the correct response from the let's say custom documents, whatever I'm asking. So this thing I'm going to show you how we can connect our large language model with our custom data. Okay, so first of all, I will draw the architecture, what we are going to perform. Then I will start with the coding. So here we'll be implementing one basic RAG. Okay, and whenever I'm talking about RAG, that means I'm talking about my custom data. So it can be any kinds of document. So let's say here I can consider custom. Okay, custom data. So it can be any kinds of data format. It can be PDF, it can be TXT, it can be Excel, XML, JSON, anything you can consider. Okay, so I'm just calling as a custom data as of now. So first of all, what I have to do, guys, is custom data. Anyone remember? If I want to perform the RAG operation, so I can't directly pass this data to my LLM. Okay, so for this, first of all, what I have to do, I have to perform the splitting operation. So we'll be performing the splitting operation. Okay, splitting, or you can also call it a chunking. Chunking. So after getting these chunks, what I will do, we'll be using one embedding model. Okay, embedding model. So in case you can use OpenAI embedding model, you can also use some open source embedding model, you can use Grok API, it's up to you. Then after that, we'll be creating vector embedding. Okay, we'll be generating the vector embeddings. Then we'll be storing this vector embedding to the vector database. Vector store, or you can also call it as vector database. So this will become my knowledge base. This will become my knowledge base. Okay. Then what will happen? User will, let's say this is the user. User will ask some query. And your vector is stored. That means you will be creating a retriever here. Retriever. Okay, retriever here. So it will give you some rank results. Rank result. Okay, based on the k parameter. So here I can write top k. Okay, based on the top k parameter. So let's say it has given you 3 response. Okay, 3 response. Let's say k is equal to 3. It will give you 3 response. Now I don't need the 3 response. I need accurate response. Okay, let's say here I'm asking. Let's say here I'm asking. Let's say what I can ask. Let's say what is the capital of India? So as a return, guys, what should I get? Okay, as a return, what should I get? Definitely Delhi, right? So it should give me the Delhi, but here it is giving me some rank results. So let's say it is giving some content related Delhi, and apart from which is, let's say, relevant to the Delhi, it is also giving me that one, but I don't need. I need the accurate response. So for this, what I will do, I will use my large language model. So here we'll be using large language model, LLM. Okay, so in case actually we'll be using like ChatGPT model, but you can use also any other model. You can use Grok API, it's up to you. So here what we'll be doing, So the rank results actually you are getting. So we'll be passing this rank results to my LLM. Okay, we'll be passing this rank results to my LLM, and whatever question user is asking, okay, the question also I'll be passing to the large language model. And now what will happen? Large language model got the context. So this is called context. This is called context, okay, and this is called query. This is called query. I think you remember. I showed you one example. So here, let me show you. So here I think data loader rag demo. Wikipedia loader. I think whenever I was talking about Wikipedia. So here, can you see here what I was doing? I was searching about Tesla, and whatever data actually I was getting, I was passing as a context, okay, to my large language model. Then I was also giving the question, like tell me about the Tesla, the same thing. But now what we are doing, we are doing some more step because my data size is huge. So first of all, I have to split the data. Then we have to create the embeddings. That embeddings will be storing to the vector database. Then what we'll be doing, user will give some query, and this query actually will go to the knowledge base. Knowledge base will return some rank results, and this rank results I'll pass to my large language model as a context as well as the query. Now LLM will process, okay, LLM will process, and it will generate a accurate response. Okay, accurate response for you. So to the user. Okay, to the user, it will give me the response. Okay, so this is the entire RAG architecture. Okay, I hope it is clear. So as of now, we have created till retriever. Okay, we haven't connected our large language model. Now we'll be learning how we can connect the large language model. Okay, so now let's try to implement this architecture through our code. So let me open up my VS Code, and here I'm going to create a file. So let me name it as 05 RAG, basic RAG, implemented. So the first thing what we usually do, guys, first of all, we'll be loading the OpenAI API key from my environment, because here I'm going to use the ChatGPT model. You can also use Grok model. Okay, Grok. You can also use Grok API to load the model. Now the next thing, RAG component, and there I showed you the retriever, how to create the retriever. So first of all, we load the data, then we perform the like chunking operation, that means splitting operation. Then we use embedding model. We create a vector store with the help of vector database. Then we create the retriever. And whenever you are asking something into the retriever, it will retrieve some relevant information, okay, with the help of metadata as well. Okay, so till here we have done. Now we'll be learning how we can connect the large language model. That means the information I'm getting from my retriever, I'll pass to the LLM, as well as I'll also pass the query. Okay, whatever query user is asking, based on that, LLM will try to process and it will give you the accurate response. So for this, you can see this code is already familiar with you. So I'm importing the Python. Python is a vector database. Then OpenAI embedding, because I need an embedding model to generate the vector embedding. Then character text splitter I need for creating the chunking. Okay, so let me import all of them. So first of all, I will load the data. So let me load one data. But before loading the data, I need to import this library as well. So text loader. So I'll be loading one txt documents. So this txt document will be loading a state of union txt. So let me load it. So this is my data. Now you can also see this is the entire data we have loaded. Okay, now the next thing will be creating the chunking. We'll be doing the splitting operation. So this is the code snippet. So here you can see I'm given chunk size is equal to 1000, chunk overlap 0. And whatever document I have loaded, I'm passing to the split document. Now it will give me the chunk. So you can see the complete chunk. See, that many of chunk it has given me. If you want to see the length, you can also check the length. So 42 chunks it has given me. Okay. Then what we'll be doing, guys, will be loading the embedding model, and we'll be creating the vector embedding. And we'll be storing in the Python vector database. Okay. So let me do it. So it has created one vector database. and it is storing in your disk, okay, local disk. And now we'll be creating the retriever. So this is my retriever, guys, okay. And by default, how many retrieve parameter actually it will have? I think you know, by default it will have 4 retrieve parameter, okay, 4 retrieve parameter. You can also test, so let me show you. So I'll be asking one question. So retriever.invoke, what did he say about Ketanji Brown Jackson? So if you open this documents, so you will see the information related Ketan G Brown Jackson. Now if I ask it, so it will give me some response. See, it has given me 4 relevant response. Okay. Now you can also play with this parameter. So I think you know there is a top K parameter. You can set search KW is equal to K is equal to 1. That means it will give you only 1 information. Okay. So let's say I want to take 3. Okay, 3 information. Now if you ask the question again, now see guys, your response would be 3. Okay, you can see you got 3 information. Okay, now you can play with this parameter, it's up to you. Fine. Now we'll be creating the RAG. That means we'll be connecting our large language model right now, and here we'll be using LangChain expression language. Simple use with LangChain expression language. Okay, and today I'm not going to discuss like this LangChain expression language. For this I'll be keeping one dedicated session. Okay, so now let's create the chain. So before that, first of all, I need to import some library. So here is the library, guys. So first of all, I'm importing chat OpenAI. Why? Because we'll be using chat GPT model, that means GPT 3.5 turbo model, and I'll be using chat completion model, not the completion model. And chat prompt template. Why chat prompt template? I think you know, whenever I want to give any, let's say, input to my large language model, that means if it is a chat like a completion model, that time I also need to pass the system prompt. Okay, system prompt as well as the user prompt. So for this, we'll be using the chat prompt template. We'll be creating the prompt template. Okay, then we'll be passing the prompt. Then this is the new thing, guys. LangChain has proposed. It is available in the second generation language, LangChain, which is called LangChain expression language. And to perform it, you need these are the library: str output parser and runnable pass through. Okay, there are some more, let's say, functionality they have created. I will discuss each and everything. As of now, just try to get it as a high level. So if you want to use this LangChain expression language, you need these are the functionality from the LangChain. Okay, LangChain core, output parser, str output parser, and runnable is equal to runnable pass through. Okay, now let me import all of them. Now, first of all, I'll be creating the template. So this is my prompt template. So first of all, I'll be creating the prompt, then I'll be creating the prompt template. So this is the prompt. Answer the question based on only the following context. That means user will give the context. Context means the retriever. Okay, the vector database. Okay, this context as well as the question. Okay, so here I've already written the diagram. So it will first of all give the context to the LLM as well as the question, whatever question user is asking. Okay, now if I want to create the prompt template, I'll be using this chat prompt template function. So see guys, chat prompt template, and here I have to give the template, and this will give me the prompt. Okay, now I'll be initializing my OpenAI model. So here we'll be using chat OpenAI. That means we'll be using GPT 3.5 turbo model. Okay, great. So let me execute. Now here I'll be creating one function. I'll tell you why we are creating the function as of now. Just try to remember this function will format the output. Okay, so now this is the chain, and you can see the syntax is written with the help of LCEL, that means LangChain expression language. See, chain is equal to, I have given a bracket, again I have given a bracket. Now here I'm writing the context is equal to retriever, because you remember what is context? Context is nothing but my rank results. Okay, the retriever. So this thing I have to pass to the LLM. So you can see this is the retriever I'm passing. And format documents, this function object I'm giving. Okay, format documents, and question is equal to runnable pass through. Okay, now you will have some doubt. I know that initially if you're starting with this LangChain expression language, this would be confusable for you. No need to worry. In the next session, I'll try to discuss each and everything about this LangChain expression language. As of now, just try to remember whatever input user will provide. Okay, this input will come here as it is, and it will save inside the question. Okay, question actually a parameter. then the prompt we have prepared. See, this is the prompt we have prepared, then the model, then the output parser. That means what is happening, let me show you. So I'll open up my annotator pen. Let me select the color. See, first of all, you are see, you have given the bracket. So this bracket is called parallel. Okay, parallel runnable. I'll tell you what is parallel runnable. It will run everything as parallelly. You can see I have given too many statements. So this is the first statement, retriever. This is the second statement, that means the function object, and this is the third statement, which is nothing but the input. Now you can see here is a pipe symbol. And what is pipe symbol? This is the LCL symbol, LCEL, LangChain expression language. Okay, so with the help of this pipe symbol, we create this actually chain. Okay, now I'm giving the prompt model as an str output parser. So what will happen? First of all, you are executing this one actually. Okay, that means your context and input will come. So let's say user has given what is Tesla. Okay, what is Tesla? This is the question. So this question, where it will go to the prompt template, and it will create the prompt template. I think you remember. So how to create the prompt template? That's how it will create the prompt template. So answer the question based on the following context. So context, that means retriever. Retriever will come in the context, and question, whatever question, let's say what is Tesla? Tesla will come inside that question. Okay. Now this question, where we have to pass to the model. You can see we have to pass to the model. That means this question will go to the model. That means my large language model, and model will give me what? It will give me response, yes or no. Okay. And I think you know, whenever we are getting the response from the LLM, so what format it will return? It will return as a AI message format. Okay, but I only need the content of it. And if you only need the content, you have to use this str output parser. I think we have already learned output parser. Remember, inside I think data loader, not data loader, I think inside this one, talk with LLM part 2, we have learned about output parser. So with the help of output parser, we can format our output. That means if I want to get a JSON output, if I want to get a TXT output, everything you can customize here. So this output parser will by default will return as a string output, str. Okay, str. Okay, so this is what actually we are using. That means first of all, we are giving the context, then we are taking the input from the user, we are saving into the question variable. Okay, then format documents. What format documents will do? Whatever response actually it will give you. Let's say, see what happens actually whenever we perform the retrieve operation. Let me show you. So here is the retrieve operation. See, whenever we perform the retrieve operations, what happens? It will give you, these are the retrieve output. Okay, these are the retrieve output. But here what I need, I only need the page content. I don't need the metadata information. It's not required. I only need the page content. So what will happen? This function will automatically filter out only page content. Okay, I don't need the metadata. I only need the page content. So this will extract the page content and it will return. Okay, here. Okay, and this input will go to the model. Okay, first of all, it will create the prompt, then it will go to the model and it will give you the output. Now let me show you. So here I'll be asking one question. So the same question will be asking chain.invoke, what did he say about Ketanji Brown Jackson? Okay, now let me execute and let me show you the response. See guys, this is the response, and if you see the type, it will be string. Okay, it says str because of that output parser. Okay, so this is what our basics LCEL, that means LangChain expression language. Okay, but previously I think you remember, those who have already worked with this one older version of the LangChain, we used to use chain functionality. I think you remember chain functionality. We used to import I think chain. Okay, instead of using the like default chain from the LangChain, we have created the LangChain expression language. And see, always try to remember, it's not like that this inbuilt chain has been deprecated. No, still LangChain suggests to use that chain as well, chain functionality as well, because still chains is under development. Okay, still the chains under development. That's why LangChain is also suggesting you have to use the older technique if you want to create any kinds of project. I'm getting the correct response right now. Okay, from my application. Previously it was only giving me the related information. Now I connected my LLM. Okay, now if you ask any kinds of query, it will give you the accurate response. The architecture we have drawn, see, accurate response it will give you.